Good afternoon to all. Myself, Dr. Asik Hossain, Assistant Professor of Department of Applied Sciences and Humanities, Healthy and Technology. I am here to discuss some problem-related and basic understanding of the pigeonhole principle. So, what is pigeonhole principle basically stands for? What are the different type of problem that can be solved using the pigeonhole principle? And the real life application related to the pigeonhole principle we are going to discuss today. So, what is the basic definition of the how the pigeonhole principle came to existed? That in 1624, the first pigeonhole principle is defined and in different way that cannot be utilized for formal definition, but Richlet in 1834 formalized the definition of 1624 definition to give the mathematical aspects of the pigeonhole principle and their related problem related to their issues. So, what is basic definition of the pigeonhole principle? Pigeonhole principle basic idea is that if you have n objects and that n objects can be embedded in can to be embedded into m containers. Suppose m is the number of containers and n is the number of objects, where number of objects should be greater than the number of containers, then at least one of the containers should contain more than one objects. Or this definition can also be treated like this: if we have n plus one pigeon, and that can be that have to be embedded into n number of pigeons, then at least one of the pigeonholes should consist of the n more than one pigeons. So the formal definition basically says us that the pigeonhole principle, the number of objects should be always greater than the number of pigeonholes. Then one of the pigeonholes should contain the more than one element. And this pigeonhole principle, also known as to be the Dirichlet box principle or Dwyer principle definitions also. And mathematical foundation of this definition is basically comes in 1624, and that is formalized by Dirichlet in 1834 to use the mathematical aspect of this pigeonhole principle. So, formal definition says, mathematical definition what says that no injective function exists from larger to smaller domain. What does this mean? This means that since n plus 1 object to be embedded into n pigeons. So you have n plus 1 pigeons, and this is the number of pigeons, and this is the number of pigeon. So the number of pigeons is always greater than number of pigeonholes. Suppose we are choosing this n plus 1 to be the domain and this to be the codomain. So we see that the cardinality of the domain is always greater than the cardinality of codomain as per the formal definition of the pigeonhole principle. So if we are trying to define a function from this domain D to this codomain CD, where D stands for the number of pigeons that consists of number of pigeons, that is n plus 1, and the codomain, that is the number of pigeons, that is exactly equal to n. So we saw that the cardinality of D is greater than cardinality of CD, that is the number of elements in the codomain. So we know that to define an injective mapping, every element of the domain should have an unique image in the codomain. So for this, if this is n plus 1 element in it, so there should exist at least n plus 1 element, n plus 1 elements in the codomain to define an injective mapping. But we see that the cardinality of CD is basically n. So the domain size and the codomain size are different, and the number of elements in the codomain domain is always greater than the number of elements in the codomain. So we cannot define any biject or injective mapping for the formal definition of the pigeonhole principle. So pigeonhole principle basically restated in terms of function that no injective function can be defined from domain D to the codomain of this mapping, where domain consists of the number of pigeons, that is n plus 1, and now codomain consists of the number of pigeons, that is exactly equal to n. Similarly, if we redefine the definition for the pigeonhole principle to an extended version, that is known as to be the generalized version. So generalized version says if the number of objects or the number of pigeons is kn plus 1, and then one of the set. So, what is the definition basically says in the pigeonhole principle? If there is n plus 1 pigeons and n number of pigeonholes, then at least one of the pigeonhole consists more than one pigeon. So, this definition can be extended to some definition like that. This domain should consist km plus 1 element. Okay, and this what is k? K is belongs to the set of natural number. Then in such case, you have n number of pigeons. So this m, at least one of the pigeonhole should consist m plus 1 pigeon. So if you put k equal to 1, you see that it is m plus 1. So it is exactly equal to the number of pigeon in the formal definition of pigeonhole principle, and n is equal to, and that is the number of pigeonholes. Then you get m plus 1 number of pigeons at least for at least one of the pigeon. So pigeonhole principle basically states that for the generalized version, if you have km plus 1 objects and that should be embedded in m or n containers, then at least one of the containers should contain m plus 1 objects among these km plus 1 objects. And this definition is basically known as to be the generalized version of the pigeonhole principle. And what does this stands for? And this also states that the number of the pigeons and the number of the pigeonholes cannot be fixed as per the condition of the pigeonhole, but you can redefine that definition to the generalized version where the number of pigeons and the number of pigeonholes can be reinstated in terms of our demand, and we can redefine it. But the conclusion is same, that at least one of the pigeonholes should contest at least m plus 1 object. Here it is more than 1 and it is m plus 1 objects in the case of generalized principle. Similarly, this situation of the pigeonhole principle can be shown in the software problem, where if you put a software like this, a dryer consists of two type of socks, that is one of black type and another one is blue type. Then general obvious question is that how many socks if we put together or get, that guarantees the matching of the pair, that means blue with blue or black with black. So this question that can be solved using the pigeonhole principle like that. If you put one socks, it may be blue or it may be black. If we put two socks, then it may be one may be black and another may be blue. So the guarantee is that the pairing of the colors should not be obtained for two socks. But we put one more socks from the dryer, then it should be of two black, one blue, or two blue, one black. So at least we get a pair of same color of socks. So pigeonhole principle also similarly says that if we have the number of objects is greater than the number of the container. So here container means the number of colors, that is blue and black, that is 2, and the number of objects is 3. That is, if we put 3 socks from the dryer, we will get a pair of same color of socks. So the sock dryer problem basically says the minimum number of socks that we can put out from the dryer that shows the same color of pairing in the socks should be taken, that is exactly 3. Similarly, in the Bagge paradox system, we can utilize the pigeonhole principle to get the probability, how much probability that we can get the number of that birthday paradox will be same. The birthday means that we have 365 days, so any one of them date will be a birthday for someone. But if we choose n equal to 1, that is not guarantees the exactly birthday of any person. But we increase the number of person from 1 to 2 to 4, 7, 8, up and go 1. So when we reach the n equal to 23. So if we choose 23% at the same time, the probability of obtaining the same birthday will be exactly related to 50%. and that can be solved using the probability formula. And if we increase that number from 23 and so on, and if we reach up to 60, so if we choose 60% at a time, the probability of getting the same birthday in the same birthday will be near about the 99.4%. So it is near about 200, but we have to go through that from number 60 to 365 because we have a 365 days in a year. So the same birthday for a number of person we have to choose is basically 366 days. So if we choose 366%, then that guarantees the date of birthday will be same for at least two people. So we think of paradox. Why it is paradox system? Because if we increase the number of percent, the possibility of collapse of the same birthday for two people at least will be 23 if we choose, then the probability will be 50%. If we choose 60 people at a time, then we'll get the 99.4% of same birthday. And if we increase that number and go beyond the 365 days, that is, if we choose the number to be 366, then it always guarantee that the date of birth class for two people will be at least same when the number of people will be 366. So how the pigeonhole principle applied here? So the number of days, that is 365, that is the number of pigeonholes, and the number of person, that is the pigeons, will be greater than that n, that should be n plus 1. So 365 is n, so 366 will be needed to define that the date of birth class for two people will happen if and only if we have 366 people, then we can guarantee that this the date of birth will be class, because the probability of these conditions that the date of birth class for at least two people will happen if and only the number of people will be 366. And why are you using this pigeonhole principle? Because this 366 is the pigeons and 365 is the pigeonhole. Okay, so this pigeonholes is less than the number of pigeons, so the date of birth class is possible when and if and only that is the pigeon number of days, a number of persons should be greater than the number of days in a year, that is 365. So 366 number of people will ensure the date of birth class for every people. So similarly, if we took the pigeonhole principle in terms of a hair counting problem, yeah, hair counting cases, how it is we are thinking that if we have a city and we are trying to calculate is there exist any two people in that city that consist of same number of hair. So you cannot guarantee because you cannot collect the data or you cannot count the number of hair. But using the pigeonhole principle, we can claim or ensure at least that there exist two people in that city that will have the same number of hair. How it so, let us suppose an example. Suppose London population is millions of people. So a city like London have millions of people residing there, but the maximum hair count in that city is lies between 1.5 lakh to 2 lakh per human head. It is already counted as per the some data. So it also guarantees that at least two resident of this London city will have same number of hair. Why? Because if we choose the London population, it is in millions. That means this is the number of pigeons, so it comes under the domain of the mapping, and the number maximum hair count, that is the number of pigeonholes, is lies between 1.5 lakh to 2 lakh, but millions means 10 lakh. So 10 lakh pigeons can have to be embedded into 1.5 to 2 lakh. So at least one of the pigeonholes, that is at least two of the people will have the same number of hair. So using that technique of the pigeonhole principle, that if the number of element in the domain is greater than the number of element in the codomain, so we can define or we can claim at least any of the element of the codomain should consist same number of element from the domain. Here the codomain consists of maximum hair count and the domain consists of number of population. So hair count is less than the number of population. So using the pigeonhole principle, we can guarantee that at least two of the people among these will have the same number of hair using the pigeonhole principle. Similarly, this pigeonhole principle can also be utilized in the handshaking case. Suppose you have four friends, and how many handshaking will be possible among these four friends that can be solved using the permutation combination. But the pigeonhole principle also state that how many one person can handshake how many one of them from the rest of the other friends. So how will formalize this problem? So set up the problem like this. Consider any group of n people. Suppose we have a big group that consists of n people and number of the people should be greater than 1. Why? Because at least two people will be needed to shake hands. So if we have n people and n is greater than 1, then each person can say 0 to n minus 1 handshake. Why? Because they may decide no handshake will be possible, so 0 handshake is there between them. If they think we can shake only one time to each other, then the possibilities of handshake from one person to rest of the other friend will be n minus 1. So number of handshake is lies between 0 to n minus 1, but not all options can be offered. That means you cannot handshake with it yourself. So that option may be neglected. And how will apply this principle of pigeonhole to define the number of possibility of handshake? So n minus 1 possible option is possible for n people per handshake. So at least two of the people must shake the same number of hands. Why? So if you can define domain with the n, that is the number of people, and number of handshake is n minus 1. So that is the number of element in the codomain. So since the element in the domain is greater than the number of element in the codomain, so using the pigeonhole principle, we can define at least two of the people will have handshake more than once. That means they will handshake at least two times. So the pigeonhole principle also says that handshake problem cases that at one person will handshake with the rest of the other at least two when there will be an n number of people in that group and n should be strictly greater than 1. So this state of pigeonhole principle can be utilized to define the how many or how much at least we can define that one person can handshake two times or not. So in the sense of computer application, the pigeonhole principle can also be utilized. How? We can define that hash function. What is the hash function basically? Hash function defined like in the computer network, if we define multiple input, if these are the inputs of any algorithm, and after the compilation, the output is minimum, okay, or fixed size. Output is fixed size. It may be 1 or it may be 2. So the input is not defined or not fixed. Not fixed means the number of input may vary from 2 to infinity, but the output is fixed. It may be 1 or it may be 2. So the domain, if we choose collective all these inputs to the element of a domain, so the domain may consist of infinite element. But if we choose the output to be the codomain, then that codomain CD will have fixed, that are finite element. So we see that the number of inputs in a hash function is not of fixed type. That means it may consist of infinite number of elements, but the output is a finite number. So we can use the method of we can use the pigeonhole principle to say that the output of the domain will have, or the input of the domain will have a collision. Collision means that two of the input may merge to into single one. This may be to merge to single one, or three may be merged to single one. So collision is need to be happened, or collision will be happened 100% due to the uses of the pigeonhole principle. We can claim that. So collision here means the input may merge to a single one, And this basically the different definition of collision. It may be two, three, or more than that also. So the collision or the merging of the input will exist in case of the hash function in the computer algorithm, or we can define the detection of the collision of the inputs with the help of pigeonhole principle, because the element or the inputs, number of inputs is infinite and the number output is fixed or finite. So using the pigeonhole principle, we can define that the collision will always be happened in such case of the hash function. Or the analysis of this input and output can also be treated in the using the pigeonhole principle, that if we have two unit and output is a single one, then we can also define that the existence of the collision for these two input is also to be happen to merge the given output to be one, and the merge will happen in the sensor or any other compiler that will compile the input and output of the system. Similarly, that data compression will also be happen. What is the data compression basically? Data compression will basically happen. So suppose you have a input data of big size. So suppose you have a statement in English that always consists of preposition and conjunction. So in a English statement, if we have an English sentence, if we have preposition and conjunction, and if we increase the number of sentences to form a paragraph, so you will get similar type of preposition and conjunction will be utilized to write down the paragraph. But if you have to compile that system, you will need some more memory. So you need to input that data input to be a lower version or lower memory, and that come after compression. If we have the same value, and if we can compile that output value to the original value, then the memory allocation to each of the paragraph or sentences to the output of this paragraph or sentences will be less, and the computer function will be as fast as possible. Suppose like this, suppose one of the statements can be transferred like this to a binary value. Suppose the sentence or the paragraph is transferred to a binary digit, and that consists of 15 multiples of 10, and we can redefine this to be compression. Compress it to this value. After you have to transfer the same value, okay, same value, that is 11111010, and you can decode here, decode to the original one, that is 1010, and so on. So basically you have a paragraph or English data or any data in input variable that is of large size. So whenever you have to transfer it to some mathematical or computer algorithm or something, that will take much more of time and data also. So we can transfer that data to a binary digit, and that binary digit where data, the objects like the preposition and conjunction will come, that will compress to a single one using any compressor algorithm, and that can be transferred to a lower value, and that lower value can be easily transferred to the output with this less value of time, and that output value will decode using a decoder to the original value. So using the data compression means the memory allocation for the input and the output should be same, but the time taken should be less. So using the compression of the data size, you can redefine the you can use the pigeonhole principle to compress the original data to a lower value, and that lower value can be easily transferred from one to another function, and that can be decoded to its original value using the decoder of the function. So pigeonhole principle basically also help to compress the data to analyze the large amount of input data for any computer algorithm. Similarly, the pigeonhole principle also be utilized to define some error correction algorithm. And error collection algorithm is nowadays basically very famous in mathematical purposes because defining a new type of code that will error or rectify the data will be useful in nowadays. So Pigeon principle also help in such a case and define the algorithm, computer algorithm of any type that can also be utilized the Pigeon principle to define or at least to say the existence of something in the case of the element in the domain side. So real life application of this pigeonhole principle can also be seen in the computer algorithm as a data compression using hash function or error correction or any one of them. Similarly, the applications or the use of the pigeonhole principle can also be seen in the subset sum example. Suppose we have a 10 numbers. So the number of subsets will be 2 to the power 10. So 2 to the power 10 means 1024. So we'll have 1024 subsets. Now we can utilize or draw a conclusion that at least two of the subsets among the 1024 subsets will have the sum same. Suppose we have a subset like this. Okay, 1 and 6. It is one of the subsets of the 1024 and its sum of the subsets element is 7. Similarly, we may have another element like this 5 comma 2 that is also a subset of among these 1024 and the sum of the objects is also 7. So we see that the sum of the entries of the subset may also be same that can be concluded using the pigeonhole principle. How? Because we have 1024 different possibilities and some will be same. So codomain basically consists of sum. Okay. And sum will be same and the domain will consist of the number of subsets. So number of subsets is already fixed, that is 1024. And 1024 its sum will be some fixed number. So sum will be some fixed number or that is an integer, positive integer. So the number of element in the domain, that is the number of subsets is 1024 and sum of the elements of the subsets is basically a in positive integer. So number of element will be 1. So we can claim using the pigeonhole principle that at least two of the subset among these 1024 will have exactly the same sum or maybe it may more than one. But at least we can draw a conclusion that two of the subsets among these 1024 will have exactly the same sum, like 1 comma 6 sum is 7 and 5 comma 2 is also 7. We may get another also 3, 4 or more than that also. But the conclusion is that using the pigeonhole principle, we can get at least or some of the sets from this 1024 will have the identical sum. So pigeonhole principle can also be utilized using like these cases. The real world applications of this pigeonhole principle can be obtained in network designing. Network design means so you have to optimize the network flow. Suppose you are using the internet services. So as worldwide the internet service is going on and you have to transfer some data from one place to another place using the networking. So you have to optimize the network flow to get the maximum output or the exact output they were expecting. So optimizing traffic flow in the networking or resource allocation in that position you can solve or with the help of pigeonhole principle we can see that. Quality control, that means statistical sampling technique based on the pigeonhole principles. As you know in the census, the sampling, nowadays basically you can go through the data collection. The data collection is happened or the conclusion or inference may be obtained using the sampling technique. Suppose you have a sampling technique where you are choosing 50%. The sampling size is 50, but the original size of the population is 1000 or lakh. Okay, so the sample size is 50, but the population size is 1 lakh or greater than that. So you can utilize the pigeonhole principle to say that among these lakh people, some of the qualities, it may be one or more than one qualities, will have identical person among these lakh people using the pigeonhole principle, because the domain element is consists of the population size and the sampling size is basically the element in the codomain. So we can say that any of the characteristic of this population size population will have exactly two or more than that number of population will have the same characteristic. Similarly, computer security, that is optimizing the networking. Same case you will get in the computer security in the cryptographic proof. Cryptographic proofs or security protocol, you can utilize the pigeonhole principle, where you have with the conclusion that at least this path or this algorithm will help to detect the quality control of this system of equation. So pigeonhole principle basically utilized to define or the conclusion of existence of something, that the something will comes from the domain condition. So it may be in the handshake problem, it may be in the software problem, it may be in the sampling technique, it may be in the subset sum problem, it may be more than any real life situation, but the domain element will always be greater than the codomain element. Then we can utilize the pigeonhole principle technique to conclude some conclusion statement where the existence is necessary.